Hello, everyone, and welcome to the webinar. This is Sydney speaking, and the subject of today's webinar, as you all know, is HSR and HSM. Basically, a very fast and easy and powerful tool to be using inside SolidCAM itself. And what I'll be actually doing more in this webinar is almost like tips and tricks, where I'll be showing you the different ways to use HSM, HSR, and HSM in the program itself on different parts. And at the end, I'll show one part that's completely, a heavy part actually, that's completely programmed inside HSR and HSM. Now, reminder to everyone that if you do have questions, you can ask them at the very end. All you have to do is right-click on the where it's have the raise hand, and in the question area, write down your question. And don't forget, when you finish writing down the question, click on send. This way I'll be able to see the answer, the question at the end, and then I'll be able to try and answer it for you. Okay, so let's now get started with the webinar itself. And first, let's start with this part that we've had over here. Now, you may have seen me work on these parts before, but it's always good to work on these heavy types of parts. Now, this first part, what I'd like to do is I'd like to go through the roughing, which we found is probably the most efficient way in HSR to actually use the roughing tools itself. And I'll start off by going into HSR, 3D HSR, and we'll start with the option of HM roughing. Now, we found that probably HM roughing is probably one of the best ways to use HSR when you're doing your roughing operations. And we'll just go down a little further as we'll see exactly why as we go down into the options itself. We'll choose choose our tool, and I'm going to start off with a 16 millimeter end mill. Okay, no problem over there. My constraint boundary is going to be the entire part, and we'll go now into passes. Now let's go into passes itself, see what we have here, and see what kind of how we work with these parameters over here. Since we're doing a rough cut, we're going to leave a wall offset. And I'm going to have it at 0.5 millimeters as my wall and floor offset. Now, when working with an offset that's actually relatively large, you can actually up your tolerance. So it doesn't have to be so tight. So I can say have 0.1 millimeter tolerance. Since I'll be doing a finishing cut after this, and we're leaving this much material, I do not have to work that close of a tolerance to the part itself. This will only take up a little more, it'll take a little longer to calculate, and there's no reason for that in this particular case. Now, with my step down, I'm going to start with the step down of every 4 millimeters going down. Now, excuse me. Pardon me, I have a little bit of a cold. Now, the next parameter I'd like to touch is this one over here called step down type. And it says constant or constant and flats. Now, constant, since if are we going down every 4 millimeters, so it'll go 4 millimeters, 8 millimeters, 12 millimeters, and so on and so forth. However, if there are any flat steps in between, it will not machine those flat steps because it's exactly in between those step downs. What I can do over here is simply use the option instead of constant and flats. With constant and flats, if there are any flats in between the steps of 4 millimeters, like a 4, 8, and all of a sudden there's a 9 millimeter step, it'll do 4, 8, 12, and then go back to that 9 millimeter step and just clean over that 9 millimeter step and then continue on further down. Now let's go into our step over type. If we look at our step over type, we have 3 different types: core, cavity, and HM spiral. Core, as we all know, is where you have the outside is completely open. The outside of the part itself is completely open, and you have a core coming up from the middle of the part. Cavity is just the opposite, where it's almost like a pocket. Not almost like a pocket, it's basically a pocket where everything is closed from the outside and you have to actually go into the part itself to machine it out. Now there's one more option called HM Spiral. HM Spiral knows how to deal with both areas and also areas that are partially open, and it works on the basis of giving an offset and then a spiral-like type cut in the part itself. In most cases, in fact, in almost all cases I've found, is that HM Spiral is probably best to use in just about almost all of them. Unless you have a complete cavity or a complete core, HM Spiral is probably the best solution you can probably have for all of those, for all of the options that we've mentioned before. Let's actually use HM Spiral. I'm going to click on Save and Calculate, and it's going immediately into the calculation, and we'll see the exact toolpath that we get. Okay, let's just finish the calculation itself. As you see, it's right now doing the HM roughing passes, and we'll finish that in a moment, which is good because it's giving me a chance to drink something hot. I do have a little bit of a sore throat, as I mentioned. Okay, excuse me. Okay, as it's going up on the down on the part itself, it's continuing on down. And this is a large part, but now it's going into its linker. In other words, the linking of the toolpaths themselves. And then it will finalize the operation as shown over there. If we take a look at the toolpaths that we have over here, and I'll start running it in my regular mode over here. Let me just stop it for a moment, and you can see right away that it's actually working really nicely. It's actually coming from the outside, clearing off the corners, and then as it goes to the middle, it'll start doing more of a spiral around the part itself, as shown over there. Also going around any kind of island that it may have, such as in the area over here. So it'll do that for the entire part and give you that nice toolpath that you need. Actually a very efficient toolpath going down in the part itself. Okay. Now, for my next operation, we'll need to do a rest rough operation. Since we've used a large end mill, okay, and there are areas where that tool cannot go into, and I also step down every 4 millimeters to clear away just the bulk of material, I still have to do some more roughing on the part itself. So for that, we'll start a new operation just by clicking on Save and Copy, and we're starting a new operation, which is a copy of the old one. And with all the parameters of the old one itself, and we can just make some changes. For example, HM roughing, we can use the option of rest roughing. Tool, I'm going to change it to a small tool over here, a 12 millimeter end mill with a 1 millimeter radius in the corner itself. This time when I go down to my passes, I'm going to leave my wall set exactly the way it was before, but my previous down step was every 4 millimeters. Now I'm going to go down just every 2 millimeters. And I'll click on Save and Calculate. Note, it's going immediately into the calculation of the toolpath itself without having to go into the option of updating the stock. If you remember from my previous webinar, I have a setting inside, there's a settings for updated stock that it's special for HSR and HSM, and I'll show that for you in a moment, where if you have all the options of HSR and HSM being, if all the operations are HSR and HSM, you can use that option to make your calculation go a lot quicker by just skipping. It does not need to do that updated stock inside the calculation. Now let's take a look at the simulation itself. And you can see right now it's only working in the areas where the previous tool could not work, and going down every 2 millimeters. Now, this tool is still relatively large for this entire part, but there's still enough material for this tool to take down that warrants a tool like this. So now we can actually go to our next operation where I'm going to do another rest rough. In other words, I can do one rest rough after the other, and the next tool that I will be using will be an 8 millimeter bullnose tool. In other words, now I went down to an 8 millimeter tool. Instead of jumping directly from a 16 to an 8, I did an intermediate step of 12 and then 8. And this time when I go down in my passes, I'll go down every 1 millimeter. Again, save and calculate. And as you know, again, it does not have to check the updated stock, calculate the updated stock beforehand. And it's going immediately into the calculation of the actual tool pass itself. Okay, just a moment. Let it finish. As you can see, it's now up to 60%. Now it's going into its linker. In other words, the calculation between the tool paths itself. It's going to finish that off, and then we'll take a look at the simulation. Now, actually, let me exit over here. And before I talk about this, show you the simulation, I had mentioned to you about the settings. So just go into the settings itself. Just reminding everybody that when using HSR and HSM only, it's always a good idea to go into updated stock calculation and use special for HSR and HSM. This will make your calculation time go a lot quicker as it combines the calculation of this with inside the regular calculation of the tool pass. So you don't have to, so it doesn't calculate the updated stock for each operation. Okay, now let's run my simulation on the entire part. And actually I'm going to do it using Solid Verify. Now note when I use Solid Verify, it'll actually do the calculation and the simulation. But the simulation is kind of jumpy and it's working actually very slow, as you see here. Relatively slow. Let me actually stop this. And when I'm doing calculation of this type, when I'm doing simulation of this type, of any kind of 3D operation, whether it be this, HSM, HSS for that matter, or even 5-axis simultaneous, it's always a good idea to use, instead of the regular Solid Verify, something called Quick Solid Verify. And that's specifically designed for 3D simulation. When I run this simulation actually works much quicker than the other simulation. Now, if I were to use this simulation in your regular 2D operations, you would barely see any kind of simulation. One, it will actually jump the steps in between are too far apart, and you won't see any simulation in itself. Also, in between the operation, it does a little bit of a update, and therefore, when you have different 2.5D operations, which are really, really quick, it'll actually stop in between each one, updating itself all the time. So this is specifically meant for 3D operations as shown over here. Now, by the way, in our second operation already, and you can see that's only working in the areas where it needs to work. And it'll do the same thing for the next operation as well, as it finishes this one, and then it'll go down to the next one. Okay, let me stop this for now. Okay, and let me go into my very first operation over here. And let me just mention one thing. In my passes area, there was I'm already looking at a question that was already asked. And there was a question that was asked while I was looking at the, waiting for the calculation to be finished. I noticed that there was a question, can you use HM spiral with rest machining? And the answer is yes. The way this is done, if you go into passes, you have edit passes. You can use the option of edit using surfaces according to updated stock. By doing this, it'll work just like the rest roughing, but using the HM roughing and looking also only at the stock that's left over. Okay, I'm not going to save this. Okay. All right, let me close this part now, and then I'm going to open up another part. Okay, like I said, this part is a little heavy, so it takes a moment for it to close. And the next part I'm going to open up, let me go to Browse Recent Parts. By the way, by clicking on Browse Recent Parts, I can see the parts itself that I want to load. And I want to load this part over here. Now, I've done already the HSR operations over here. And what I'd like to do in this is show actually the different HSM finishing operations, different strategies you may want to use in different areas without having to machine every single part over here. Okay, first let me just go quickly through the HSR operations over here. And if I were just to open up the very first one, you can see that we've done HM roughing. We've used a very large tool in this particular case. This is a large part, a 30 millimeter end mill. And in our passes, we have a 0.3 millimeter step down. We have, 0.3 millimeter offset with a step down of every 4 millimeters. And if we take a look at the Toolpaths itself, you can see that it's working on the entire part using the spiral type of Toolpaths on the part itself. Note, in this particular case, actually let me start this from the beginning so we can see this again. You see what's actually happened over here. It started first clearing off the corners and then working its way around in the part itself. Note that these areas over here, let me turn this part around over here, is a little already indented over here. So it's actually over here, it's starting to go further into the part itself as it goes through the entire part. And then when it gets to the areas where it has to actually go directly in, it'll actually spiral its way in and then clear out that area as well. Okay, now of course, you can see that over there. I've also used a rest roughing operation just to clear out those areas over there. And I've done another one with a smaller tool. Now what I'd like to do is start on my finish cuts on the part itself. Now, if we take a look at this part, this particular surface over here, this is a completely flat surface. And it's a very, very large area. And the way I'm going to use that with HSM is use the option, and I'll actually open up 3D HSM, use the option of horizontal machining. Horizontal machining in the HSM is an option that actually picks up any single flat surface that's on the part and machine all those flat surfaces. Okay, now the tool that I'm going to use in this particular case, I'm going to use a 16 millimeter end mill. Okay, we'll select my tool. Constraint boundaries, I'm going to actually use I'm going to actually use the entire part again. I'll take the entire part. In my passes, and all I want to do is go down to this surface over here. So I'll go down to that surface over there. Okay, I don't want to go down all the way to the bottom. I'm just interested right now just going up until that surface over there with this operation. Now, one more note that should be taken over here is we have something here called detect core areas. By using detect core areas, since I can actually go into this flat surface from the outside, the detect core areas will recognize that and actually work in from the outside of that surface. Let's do a quick calculation of that operation there itself. Okay, it's actually going down and calculating the entire toolpath itself up until that surface. We're just about done now. And remember, I did say that this was a large part. If I remember correctly, I'll just check it in a moment. The part itself is about 600 by 600 itself. Okay. Let me just run my simulation, and you'll see that the toolpath is on the flat surface over here. Okay, that's all I wanted to surface machine out in this particular case. Now, next, I like to work on these surfaces over here. Now, in this particular case, I'd like to have my toolpath exactly according to the shape of this area over here. So for that, I'm going to use a different option in HSM. And the option I'm going to use is called 3D Constant Step Over. 3D Constant Step Over actually allows me to define a shape by a specific boundary, and it will actually work on the surface according to that shape. Well, let's see how this works. I'm going to use a tool that's a ball and mill. In this particular case, I'm going to start off with a 6mm ball and mill. Okay, you can see I have my holder there as well on the part. You can see that on my screen over there. And I'll just select that tool. Now, my drive boundaries in this particular case, I'm going to do by creating manually. And I'm going to do selected faces. If I go to my creating my boundary over here, we'll define the actual boundaries that I want to use. This, I want to pick that surface there, that one, and that one. That's going to be my actual boundaries. Okay? That's my actual drive boundaries. You can see if I click on show, that's what I've chosen over there. Great. Now it's just building the actual boundaries itself, taking into consideration also the diameter of the tool that I'll be using. Now, I'm going to finish this in a moment. And if I take a look at the toolpath, you can see that's my actual boundaries that'll actually create the shape of my toolpath itself. Now, in this particular case, my constraint boundaries, I want them the same as my drive boundaries over here. Okay, so we have selected faces D633. That's the one I want to use. So if I go into create manually and again selected faces, I can use that geometry that I've done over there as well. My passes are going to live right now every 1mm so you can actually see the toolpath itself. And if I do save and calculate, it's going to do exactly that. Now, what you'll note in this toolpath that it's creating, it's going to work exactly according to the shape of that boundaried area over there. That's the drive boundaries that I gave. It's going to use that shape as my toolpath, and the step overs will be exactly equal no matter what angle the surface itself is on. And we'll see that in a moment as soon as it finishes calculating. Okay. Okay, we're almost done with the calculation itself. Now, if we take a look at the simulation, just a moment, there we go. You'll see it's working according to the shape of that area itself. And if I were to zoom in, you can actually see it's an actual very, very even step over on that surface. And it works on that entire surface over there. And the same thing on this surface over here. It's going to do the same thing over here. And you know what I've noticed? I've noticed in this particular case, let's look in this area over here. You see in that particular, let me actually stop it. look what happens over here. Even though I pick the entire surface, this area over here has not been machined. Well, the reason for that is very simple. The tool that I'm using, okay, let me try to stop it somewhere in between over there. The tool that I'm using, there we go, let me stop it right there and put it on the side. This holder, if I go down very deep, or when it goes down very deep over there, would actually crash into the material over there if I were to go all the way down with the tool over there. So HSR, HSM, and HSR as well takes the tool holder into consideration when it builds its tool paths. So what do you do in a case like this? Well, one of the things I could do is I can say, you know what? Let's use the exact same tool, but instead of this type of a holder that I've used now, I've already created one over here. I'm going to use a holder that it has, and we'll see it in a moment, a shrink fit instead of what we had before. This will actually allow me to go a little further deeper. But not only that, I also let it stick out another 10 millimeters as well. Okay? I'll choose that tool. Redo the calculation. And you can see over here, by the way, in this window also as well, that the tool has what they call a holder clearance. That makes sure that the holder will not hit any part of the stock or the target as well as it's working on the part itself. That's why it did not machine those those areas over there. So by changing my holder in this particular case, which in many cases that just may be the whole that may be enough, we can actually go a lot further down into the part itself, and we see this in our simulation. Okay, the simulation is about to start as it finishes the calculation over here, and as you can see, this time the tool is going further down into the part itself. Actually, this over here we don't see it, but we'll see it over here in a moment. You see now it's going much further down into the part itself. Okay, I could have gone up a little more. Like it looks like I have one pass that wasn't at the very corner, but you understand just by making those little changes, I was able to go further down. And this is actually very important with HSR and HSM that it has that that clearance that you need over there. It checks the clearance for the holder, and this is also very good. So sometimes you're working in a deep pocket, and when working in a deep pocket, sometimes you want to actually, you may want to go very far down with the tool, but you're holding it very short in the holder itself. This will make sure that the holder won't hit the material, but rather changes its tool path and works wherever it can. Okay, and that's exactly what happened in my previous case over there when I had the bigger bigger holder over there. Now, one more operation I like to do over here is, first of all, I like to work in this area over here. Now, there's several ways to work in that area, but what I'd like to do is to work on this wall, which is on a slight angle, and to work on these areas over here as well. So you know what? I'm going to choose a different type of operation of HSM. And this time, you know what? Let me just do what I did before. I was in this operation over here. I'll just do save and copy because I want to use the exact same tool. But this time, I'm going to use the option of 3D corner offset. In my 3D corner offset, if I go into my constraint boundaries, I'm going to use the option of create manually. But this time I'm going to use a user-defined boundary. And my boundary in this particular case is going to be, I've already created before, this area over here up until that edge over there. And I'm going to say not centered but internal. Because I want the tool to be internal of that area over there. Looking from the top, you can see this is the edge I picked over here, and this is the center of the tool, which is internal to that area over there. Okay, Now I have my pencil passes, my passes itself, my horizontal step down and step over. Now what you'll note in this particular operation is the tool pass. In the flatter areas, it'll go from the middle out, and we'll see that in a moment. But on the steep areas, it'll actually go from the top down. And let's see exactly what happens in a moment. We'll run our simulation. Let's zoom out a little. Yeah, it's better. As you can see, it does the middle area over there, and then work down on the wall. So a little slower, so we can get a better glimpse at it. Works that area over there, that flat area, then works down in these steeper areas over there from the top going down. Okay. Now, there are all different types of ways to work on this part itself, but I just wanted to show you some of them that people don't always work with them because they don't know about them. So I wanted to bring this to everyone's attention as well. Okay, now the next and last part I'm going to use is actually a part that's completely built from beginning to end. I've done all the operations. It's actually a very, very large part. And it looks like, it doesn't look like, this is the actual part over here. And like I said, if I remember correctly, this part, if I looked at the file, it was about 500 megabytes. So it was a half a giga as far as the size of this particular so it takes that a little longer to load, but which is acceptable. But it did load actually relatively quickly. Okay, now this part I've completed from the very beginning to the very end, and actually I've machined this part. And I'll show you actually after we've done this part. After I go through the operations that I've done over here, I'll actually show you some pictures of the actual part itself that I have. Okay, now again, I started off, and this is the way we actually did this. This is a mold, and we've done roughing operations over here, and we did what we call semi-finish operations, stage 1, semi-finish stage 2, and then finish operations on the part itself. Okay, now the first operation, like I said, was the roughing operation, and again I used the HSM roughing, and the tool in this particular case was a 25 millimeter end mill, and we used actually a 25 millimeter end mill that had which was a bull nose, which had a radius on the tip itself. Which is always I've been told it's actually true, which we can actually better in many cases when using doing a rough tool machining on the part itself. It's better for the corners of the tool itself as well, and you can also get in closer to the part because of those rounded corners. There's less material that's left over in between steps. Okay, my constraint boundaries was the entire part, and in my passes we left 0.3 millimeter offset on the wall itself. If I take a look at the simulation, you'll see that's actually working on the part from the outside on the entire part as shown over here. Okay, let me actually do this using the option of Quick Solid Verify. Okay, and it'll work there. You can see exactly what it's doing, working in this area over here now as well. And it'll go, let me actually speed this up a little. There we go. And it'll work down on this entire part until it gets to the very bottom of the part itself. And then, of course, it'll go over to the other side over there as well. Okay, now let me stop this simulation. And let me explain now my next operation. Now, my next operation, obviously, since I still have large steps on the part itself, we did a rest rough operation. As you can see, I used the option of rest roughing, and I used a 12 millimeter ball and mill. Again, my passes, this time my step down was every 2 millimeters. Again, looking at the simulation itself, let's go actually into HostCAD. You can see that's only going to work on the areas where it needs to work itself. Going down on these surfaces over here, not wasting any of the air time, cutting in between areas where there are no material because we're using the option of rest rough. Now, let's go into HSM now. Now, like I said, when we machined this part, we wanted a really nice finish. So when we machined this, we said, okay, when you're working on a really nice finish from a roughing cut, you first want to do some semi-finish operations. Okay, so what we've done is in the first operation of my semi-finish, actually stage 1, because we actually did two levels of rest rough of semi-finish to get as close as possible before we did the finish itself. So in our first semi-finish operation, all we did on the entire part was a linear machining going back and forth on the part itself. Again, my constraint boundaries was the entire part, and my passes, we had a step over of every millimeter. And since I wanted to work this way on the part, I said, let's work at 90 degrees on the part. Okay. Taking a quick look again at the simulation, you can see that the toolpath is going back and forth on the part, a linear operation. Now this is every millimeter, but it's also staying away from the surface. It's not exactly on the surface itself. Let me actually show you this to you as well. We stayed 0.2 millimeters away. Notice we went a little further in, but not close enough yet. Now, for my next operation, since we still have these radiuses, these corners over here, and there's a lot of material left over there, we've done a rest machining operation just for those corners, where I've taken a 10 millimeter ball end mill to work into those corners itself, and my reference tool was 12 millimeters, the 12 millimeter ball mill that I used before. And my passes, my wall offset is kept the same as my previous semi-finish operation, and going down every 0.3 millimeters. Quickly looking at the simulation over here, you'll see that the tool actually goes down and works just on those corners. Now remember, this is a first stage semi-finish operation, and we just want to make sure we have at least amount of pressure on the finish tool at the very end. This is why we've done this in a two-stage step down on the part itself. Now my second stage step down is actually the next two operations. Now the next operation itself, I've used the option of hybrid constancy. What I want to do actually over here is to work on the part itself as shown over here, but I want to have it very close to the type of toolpath, the type of finish I want to have on the part itself, but I still want to have a little material left over. Now, hybrid constancy, the type of toolpath that I'm going to get over here is sort of a combination of constant Z and 3D constant step over, where in the steeper areas it'll work with the constant Z going down, and then in the rest of the areas it'll finish it off using the 3D constant step over. Let's actually take a look what we've done over here. I've used a 10 millimeter ball end mill, and since this is my second stage of a step of my step down of my semi-finish, we have a wall offset this time of 0.1 millimeters. My constraint boundary, I'm still using the entire part, and if I run my simulation, you'll see the constant Z toolpath on the part itself. That's what you see right now. This is actually working Constancy on the steeper areas. Same thing down here. It's going down Constancy. Now, you'll note when it finishes the steeper areas, let me actually zoom in a little, as shown over here, it's going to start working in these areas over here. And you'll note, now it's working, sorry, there we go. In these areas over here where it's relatively shallow over there. And this area was a little flat where it didn't work before at all. The 3D constant step over actually worked in that area. Same as this area over here, over here, over here, and around the entire part itself. Now, again, for my next operation, which is again a semi-finished, the last stage of the semi-finished operation, options, was again rest machining for the corners using a small end mill, a small 6mm ball end mill, and my reference tool again 10mm, and my passes, my wall offset still set at 0.1, but leaving a step down this time of 0.2mm on those corners. We're getting now pretty close to the finished cut itself. Again, running my simulation. You'll see it in a moment. You can see that it's working exactly in those corners, exactly where I want it to work. Okay, only working whereas the 10mm end mill, ball end mill could not go into. Okay, now I'd actually like to go into my final operations to finish off the part. And this is exactly the way we did it also on the machine itself. First, we used a linear operation. Now, when I went into linear, as you see, we used linear operation, linear machining. The tool was my 10mm ball and mill. And my constraint boundaries this time is I did not want it to work on the entire part. I just wanted to work in specific areas. This area over here and these areas over here. So what I did was as follows. My boundaries was this area and this area over here. That's all I wanted to work on with my linear machining. Okay. My passes, we have a step over of 0.04. No, with 0.04 of a millimeter step over on this particular area over there. Those areas over there. And note the following. I have my defined angle working at 45 degrees on the surface itself. If we take a look at the simulation, you can see that 45-degree angle working over here. Now, the reason that it was done at a 45-degree angle is that there are many people that say that, and this is, I've also seen this, is that when working for nice mirror type finish, you're better off working at a 45-degree angle, not exactly either 0 or 90 on the grain of the material itself, but rather this way, and you'll get a nicer finish. Now, again, you can work any way you want to, really. But this is the way we actually found that it worked pretty well with us, and we really got a nice finish. Okay? Now, in my next operation, I wanted to continue in this area itself. So what we did in that area was we used the option of hybrid constant Z. Just like we did before, but this time when we used the hybrid constant Z, I used my 10mm end mill, but my constraint boundaries this time was this area as shown over here. Only this area. Okay? And my passes again was a step down of 0.04. Notice we really had a nice tight tool pass on the part itself. Now, I'm not going to show you this simulation because since we have really tight tool pass over here on the part, it'll take quite a while because this is a really, really tight tool pass. But what I did was, just to show you how the tool pass actually does look in any case, is I've copied that operation over here, And I've just changed my passes to 1 millimeter so you can actually see it a lot quicker. If I run my simulation, you can see the Constancy passes over the part itself, as shown over here, working in these areas. And then when it finishes those areas, it'll work with the option of, as shown over here, working with the option, finishing it off using similar to the 3D constant step over. That's what the combined, that's what the hybrid Constancy actually does. It sort of combines those two options, those two operations into one in this particular case. Okay, now obviously I still need to finish off the corners. So for that we have the rest machining. Now this time, since this is a really nice finish I would like to get, I used the rest machining as shown over here, and I've used my 6 millimeter ball and mill. In my reference tool, instead of using 10 millimeters like I had the actual tool that I used before, I actually gave it a larger reference tool, giving it an overlap between the two surfaces that I need over here. By giving this overlap, we get that really nice blend between the tool passes. Again, my link and my passes, I've used a step down, step over of 0.04 to get that really nice finish. I'll just run a simulation as quickly as I can over here. You'll see it in a moment. You can see that the tool comes down, works really, really tight on the part itself with a 0.04 step over inside on the tool path itself. It'll finish this area. Let's zoom out a little. You can see it work, actually zoom in a little. You can see it working over here as well. We have a really nice tool path over here going around. You can see it actually working in from the top and from the bottom, as shown over here, of 0.04 millimeters. And it actually does this around the entire part. What I'm going to do right now, right before I finish, is actually show you some of the picture or two that I have actually of the part. Because as I said, we actually did machine the part itself. This is the actual part after it came off the machine. Really nice, smooth. This is 0.04 step over on the part itself. Okay, and this was done exactly with the program that I had just showed you on the part itself. Let me just give you, maybe I have two more pictures I can show you. I can show you how it looks from this angle over here, these surfaces over here, these corners over here as well, and from the flip side as well. So you can see, you can really get a really nice, smooth, clean mirror type finish on parts using HSR and HSM. And this was a good example for doing that. Okay, let me just look at some of the questions we have here. One question was, does Quick Solid Verify work when you are machining prismatic parts? Yes, if you the operations, a 3D operation, it'll work in any case. In all cases, it'll work. But when you're using the 2D operations, it'll be too jumpy in the part itself. However, using it on prismatic parts, if you're using 3D machining, it'll work there really, really well. It'll work there just as well. Okay. Someone asked me over here, how long did it take to machine? If I remember correctly, it took us about 19 hours. This is a very, very large part. Okay. Again, for mold machining, this is very, very acceptable. Okay. there's one other question over here. How can I set check faces in HSM if I'm using user-defined boundaries? User-defined boundaries, you do not have check faces, as you know. You wouldn't use user-defined boundaries if you wanted to have check faces. Then you'd use the option of, let me see where I can go into here again. Let me just go into here. You would use constraint boundaries, selected faces, and that's the only place where you really have the drive faces and check faces. User-defined boundaries, you cannot use check faces. Okay. Again, these parts will be available. The recording will be available tomorrow on our site as well. Just a quick reminder, the site, where do you find it in the site? It's, let me see. If I go into the site itself, if you go into webinars, webinar recordings, you'll see the recording over here. If I were to click on one of the recordings, for example, let's say this one over here, you can see they have clicked to download the video or play the video, and you'll also, since I can give these parts, you'll also be able to get the parts by, there will be a link on it for clicking for downloading the parts that I've used. Okay. Thank you very much for joining the webinar. Now, next week, there will not be a webinar. Next week, we'll be having a little bit of a vacation. But in 2 weeks, will be our next webinar. So everyone have a great weekend and enjoy. Thanks for joining the webinar itself.